Testing within the Cocos2d-x GUI can be rather challenging, but I found that if you pair the Cocos2d-x GUI up with the catch header-only library, it actually works fairly well. So first thing we'll do is we'll create a little basic hello world Cocos2d-x thing, application, and so we'll just create this in the command line. This could be Windows, this could be Mac, could do it in Linux. It's all fairly platform agnostic. We're going to be primarily working with the desktop tonight, but it's pretty straightforward. Anyway, we're just building the Cocos2d-x framework here just to get it out of the way. So we'll have the basic Hello World app. Now, really what we're doing is we've got the app. We're not going to change this too much. So the first steps we're going to do is to create a test scene, because you don't want to be running your main scene first. We're going to sort of call the Hello World scene to be the main scene in this case, but you don't want to call it first because you're going to want to unit test potentially that scene. All the unit testing is going to be done from the app delegate, but of course we need a second app delegate for running our test framework. And so first we're going to do is we're going to create this test scene, and we're going to make the test scene basically a duplicate of the Hello World scene, except we're going to remove most of the Hello World material from it because we need it to be blank. And so now we're just taking 3 new scenes, scene 1, 2, and 3. They're just 3 scenes from our application, like just our imaginary sort of application, and just clean out all the comments here to shorten the code. And then we just copy the Hello World code to scenes 1, 2, and 3. So basically scenes 1, 2, and 3 are 3 Hello Worlds. Now one modification we've done is the close button is no longer closing the app, because that's where we're going to do most of our work right now. It just says printf do little, because it does so little. So we change the various function names, we build it, and so now we need to create a, we'll just clean out the test scene so that it's basically blank. Now we need a new target, and the target's going to be a unit testing target. So we'll duplicate the desktop target. Now for testing the iOS, we would duplicate the mobile target and create a second unit testing framework. Now for some reason Xcode, when you change the name here, doesn't actually seem to change the target name. So we're going to have to go dig around for the Manage Schemes button. Let's go here and Manage Schemes so that we can change it again, so that we rename it twice. I don't know why. It's an Xcode thing. Anyway, once that's done, it's out of the way. And we're going to be adding the testing to the unit testing target, and we're going to be keeping the app delegate, its default, which is the desktop and mobile environments, because the app delegate will continue to run the normal startup code and not do any testing, whereas we're going to create a test delegate, which is effectively a duplicate of app delegate, with the tiny exception that test delegate is going to call our test scene, which is really just a placeholder scene so that it has something to begin running the Cocos2d environment without really doing anything beyond that. So we'll bring this and the catch in, and of course this only goes into the unit testing target because we don't want it to be part of the normal targets. There'd be 2 app delegates and it would cause great confusion. So anyway, so here we have the traditional app delegate, and we have our test delegate, and they're part of different target memberships, as you can see over on the right. The app delegate is the traditional, and the test delegate is only in the unit testing target. So we want to now go into the test delegate, and we want to begin adding some catch code to that. So now the catch header-only library is quite interesting because the catch, actually first thing we want to do is point the test delegate to the test scene and not the hello world scene. So we'll just change that to test scene. And if we were to try running it, it won't work because it's pointing to the hello world scene down below, which is best highlighted through a failed build. There it is right there. Change that to test scene. And now if we run it, it runs and we get a blank screen. Because remember, we took everything out from the hello world stuff, took all that. And so this scene effectively does nothing. Whereas if we go back to the normal desktop and run that, it will run the hello world scene just per normal. So now we will start adding the catch framework itself to the test delegate. So the catch framework is quite interesting because what it allows us to do is most testing frameworks, unit testing frameworks, have their own main function. But the catch one is one of the ones that does not have to have that. It will if you set the right define. But if you set it to catch, so let's clean out the comments here, make it the code cleaner, easier for us to scroll through. We'll set up a testing group so that we can keep the testing stuff simple and slightly separate. So what we're going to do is we'll add the catch config runner. Catch config runner. And the catch header library, and you have to make sure you put the catch header library after the catch config runner because there are if-defs inside it that will get confused if you don't have it. If you try doing it the other way around, it won't be terribly happy. So we can do some test cases here, and it's pretty straightforward. It's a straightforward unit testing environment so that you can do your tests. It's not really that different from almost every other unit testing environment out there. I find it quite clean and quite happy with it. So now we'll just set this very simple test, which won't run. So we'll quickly run it, and you'll see that nothing came up when we ran the thing. And it's because we're not running the test yet. There is no instantiation when we're in test config runner. If we were in test config main, it would have tried creating a main function, which would have collided with our existing main function. So we create a test session after Cocos2d-x has done all its work, setting up the director, and there we go. You can see in the debug that there was a hello there, which is our only code running in the test, and that a test ran and oddly enough passed. And so the catch testing library has all the usual macros for this and that. As you can see, here's a nice warning, shows you what line it came up on. It's a clean, it's a nice environment. I'm really happy with this. It's definitely my favorite unit testing environment this week at least. So we'll just set up a little test failure here to show you how wonderful it works. A lot of them will not dig too deep into what you're doing, whereas this one, like for instance, here we go. It's not only showing you that x is not equal to 5, x being 3, it actually shows you 3 is not equal to 5. So it's quite clean that way. So anyway, now we need to start actually GUI testing. So we're going to bring a hello world scene in here. And this is where it actually gets interesting. So you think that hello world is the scene, but hello world isn't a scene. Hello world is a layer. So say we get an error, and so we can't replace the scene with a scene because we haven't asked for a scene. We've actually asked for a scene and then assigned it to a hello world object, which is a layer, when in fact we should be saying no, put it into a scene. And then that's going to be happier. Which is really where this Cocos2d-x becomes very difficult to test, but yet there is a solution. As you can see, we ran in it. Our test actually ran a hello world. So now we want to run a member function here. So we'll just rename the member function a little bit. And there we go. So what we have is we have a hello world scene with a member function that has that, and we can run it. But how do we run it? It's a layer. It's not actually a scene. See, if we go here, you can see that the type, it's returning a scene, but the hello world itself is a layer. The layer is the first child of the scene. Now we could assume and just ask for the first child, but I don't like making assumptions like this, so we're going to set a tag. We're going to tag that layer, which then will allow us to later ask for that layer, which is truly where member functions and whatnot lay. Our member functions aren't member functions of the scene. So we're just putting this define main layer. Later on we'll put it into a header comment header that but for now we're just going to put it here as a theoretically global definition. And so now we've set the tag here. Then we go back to the test delegate, and as if we'd imported it from some global, we then have it defined here. And now we can say, give me the layer by getting the child from the scene. We have to cast it because, of course, it's not a layer, it's a hello world, so I was just saying. So we need to switch that over to a hello world. So the layer is a hello world, and now from that layer we can call the member functions, which if I click Doolittle, and it takes a pointer to something, but we don't use the pointer, so we'll just send it an all pointer. And there we go. Now, not very interesting, but we called the member function of a layer in a GUI, Doolittle. Boom, there it is. Now we've got that's progress, but we're still not all the way there. We need to have some kind of common place to store what layer is presently active, because of course we may have instantiated the hello world layer, but the hello world layer may very easily instantiate other scenes with their own layers, may replace it, may push it. It could be popping layers. You just don't really have, well, I shouldn't say you don't have control, it's your app, so you do have control, but it's a dance. You know your scenes are coming and going. So first thing we're going to do is, under the pre-processing, we're going to effectively add a unit testing define, so that at any point inside the app we can ask, are you unit testing? And this is only for the target of unit testing. The other targets don't know about it, so it won't be defined. So as an example of this, we will go to desktop. We're going to, so we can see Doolittle runs when we're in desktop mode. But if we switch in an ifdef to see if it's in unit testing mode, which the desktop mode is not, of course, because it doesn't know about it, we run it, we click it, and nothing appears. To click, nothing. But we switch over to the unit testing, we run that, we click on the button, and we get an effect, because of course it's been killed by the ifdef. The code doesn't exist outside of unit testing. And we're going to use this heavily in the unit testing. So one of the first things we're going to do is go into common crap, and we're going to move that define. I hate .hpp for some reason, it just annoys me. So anyway, so we're going to move the define main layer into there, and then we will begin just importing, or including, sorry, been doing too much Python. It will include the common crap, which then of course brought that main layer definition in, and we'll go in here and do the same thing, kill that main layer, place it with the include, everything runs just as it should, no crashing. Now we're going to create a singleton, and the singleton's going to hold what the active layer is. Now we're going to need two parts to this, but as right now we're just going to create a common crap namespace, and then we're going to put a setter and a getter for the present layer. We're going to need to do a quickie include of the, or using of the Cocos2d-x. So yeah, so we'll put that there, the using, that's the macro for Cocos2d-x, so it's using that, so I don't have to put the Cocos2d-x in front of everything. And so we'll put a getter and setter, it's a layer, and then we'll set our singleton static. So there will be a effectively global present layer, and because really everything I do only has a single active layer. Now, of course, if you've got some funky code where you've got multiple layers, you're obviously going to have to change this approach, but this at least will give you hopefully a pointer to the direction you want to go in. Okay, so now we've got a getter, a setter for present layer. Now later we're going to need to store what class it is, and but for now we're going to just leave it as it is. It's not sufficient, but we're going to need more. So we have to def that into the unit testing. Now, for every scene, we need to set that layer into the present layer. So we're going to put that into its namespace. And so there, the singleton is setting the single layer. So now we know when hello world is run that that layer has been set. Now we're going to have to set that eventually into each scene 1, 2, and 3. But first we're going to include scene 1, 2, and 3 because they have to come into existence somehow within the app, and we're going to have them come into existence from within the hello world for now. Eventually they'll be even able to call themselves. But now, one of the key things is often as the app does its little dance, you don't, oh yeah, we got to put that in a namespace. As an app comes into, the scenes come into existence, there's not a lot of control, so we're going to keep it completely out of control by randomizing what scenes are being generated. Every time you click the button within Hello World, it will generate a new scene. So we're going to pick a random number between 0 and 2, or up to and including 2. From 0 to 2, I guess I should say. And we're going to, I think we'll just put this to a universal scene variable. Now keep in mind, I'm not doing any deletes or anything here. This is not a C++ coding tutorial. This is a getting unit testing to work in a GUI tutorial. And a lot of that boilerplate code will just make this tutorial slower. And I will assume you are a good coder. So we'll just replace the scene with the randomly selected scene. And we'll have to put a seed there in a second, but let's just see how this looks. And oh, I did an overly zealous search and replace. There's only one hello world PNG, and I need to, I was searching and replacing hello world when I created scene 1, 2, and 3, so there we go, put that PNG back. It all runs, and there we go, we got, well, it's hard to tell that there was a scene switch. So what we need to do is we need to distinguish scenes 1, 2, and 3 from hello world, seeing that they're all sort of copy and pastes of the hello world code. So we'll just make them visually and debug-wise, debug window distinct. So there we go. Now when we run it, it would help if I didn't use double quotes. Now when we run it, it will, it says scene 1, we run it again. We get, well, bad luck, we got scene 1. Oh, I know. Coding 101. We've got an seeding problem. So we need to do a intro to programming, third lesson, random numbers. There we go. Seed your randoms. So we're getting different scenes randomly coming up. So now we need to copy this code into all the different scenes so that the scene layers are being set. And what we're going to eventually do is we're going to build a kind of recursive situation where each scene can call scenes below. It's not quite recursive because we're not pushing them onto a stack. It's a replacement, so you can't go back up the stack. But it's kind of recursive. So we'll just see. So now what we've got is we've got a problem. If there'd been some kind of thing calling a thing, we don't know what the layer name is. It could be hello world, but then if hello world can call a if it can replace itself with scene 1 or 2 or 3, we don't know what the class name is. So we need to keep track somehow of the classes. And since there's no reflection inside C++, or maybe with C++ 14 or 17, there is, but it's a feature I'm unaware of. We need to keep track of that ourselves. And since it's our app, we know we can make a list of functions. So now one way to do it would be to create a nice little enum or something like that. But I'm going to keep this very clean. And I'm going to just take an integer, pass it along with the set present layer, because of course you're always going to set the present layer simultaneous to the class. And so we'll just set up a series of defines. And we'll just pick 10 for hello, and 1, 2, and 3 for, well, 1, 2, and 3. Some enum, as I say, would probably be far superior for this, but I want clean and simple. This tutorial is going to be long enough as it is. So we then go in here and we set another singleton for the integer. And we'll change this to who's running. And then we set it here. Now, we could try returning a tuple from getPresentLayer, but I'm just going to create 2 getters for the single setter. It's just simpler. And now we need down here to set that class name in each one of these setters for the setting the present layer. Again, this is all being if-def'd out, and it's only existing in unit testing, so it's not necessarily making your code go to hell. It's a sort of separate spaghetti to go beside your normal spaghetti. And so now we'll just load into a variable from the function. I don't like putting functions as the switch expression, so just find it sloppy, unclean. So now we know what class it is, which means we know what member variables it can have, so we can make decisions based on who's coming in, which classes come in, and we can say, okay, we know you are a hello world. And so we'll have to put this into a scope because I'm using the variable new layer over and over again. So we'll just scope that out before calling the function specific to each of the classes. So we can go, hello world has that. But you'll notice that when we start switching these over to scene 1, 2, and 3, remember I renamed the function click but do little. So there is no click but do little member function. I renamed it something click do little, I forget. And yeah, we have to actually include the headers for the screen 1, 2, and 3. That would help. Which is why the click buttons weren't airing out earlier. There we go. See, the 3 buttons have There's no member function because we know what class it is. We're able to call member functions appropriately. And those three have three different member functions than hello world because I renamed it. Get rid of this function here. It's not needed anymore. So we can run this, and every time we click, or every time we run it, we see a new thing. So we'll just rename this function to show that it truly is a separate function from scenes 1 and 2, and so when we call it, it's a very separate member function that only 3 has, and scene 3 has it. All is happy that way. So now, let's start sending this into the recursion. We'll put the hello world random code into scenes 1, 2, and 3, rather than just the print statement. And so now each of the classes can call, or each of the scenes effectively can now replace itself with another scene, and that can go on endlessly. So scenes 1, 2, and 3 will replace themselves with every click with a random version of either itself or one of the other two. So see, we click and we get a new scene, or the same scene, but it's being replaced. And so now what we'll do is we'll show you just how potent our GUI pounding can be. So what we're going to do is we're going to run this. We'll put this into a for loop, maybe 100 for loops, or a for loop that runs 100 times, I should say. So we've got, we have run it 100 times, indent that even more. I don't like indenting that much. Don't even have comments at the end. As I say, we're not making magically great programming. We're making this work. And I've screwed up with a coding 101 seeding error again, so I need to go, as you can see, it's just running scene 1 over and over again because it runs it 100 times in the same millisecond, which means we're getting the same seed 100 times. The same seed generates the same random. So we'll just go into each one of the things, we'll just pull the seed out. We'll utilize the seed that's happening in hello world as the only seed, and you should only seed once anyway, unless you're doing procedural generation or whatever. But anyway, it's now that should work perfectly. There we go. Just randomly going deeper and deeper down the rabbit hole, and as each class comes in, it's properly running the member function. And there we go. I mean, everything else beyond this is some variation of what we've already built. We can run it 1,000 times. We can run it 10,000 times. And as you can see, if anything's slowing it down, it's the debug window. That's the slow part. Now you'll notice the transitions here aren't transitions, they're just replaces. I often if-def out transitions because they do tend to slow down the testing process. So I use those if-defs within the unit testing and say, don't do the transition, just do a replace scene instead. And yeah, anyway, thank you very much. Like it, subscribe, and all that stuff. If you have any questions, just ask in the comments. And if you have any questions about Cocos2d-x, if you have any questions about C++, about the catch testing environment, or yeah, anything in this whole area, I'm actually interested to see what kind of questions you have. I think I've kept this under 30 minutes, yeah, 29.5 minutes. So I like to keep things short and simple. If you have any comments that are also showing something I've done wrong or I could do better, I'd love to know that one. Yeah, so there we go. There's unit testing. As everyone knows, you unit test your projects or you get your project shot in the face. It's just that simple. Any project beyond a very small size, you end up in a near infinite loop of creating bugs is fast or faster than you can fix them if you don't have unit testing frameworks in place. So that's always been a big gap with my Cocos2d-x GUI aspect of the development. The model behind and the view behind, or the model and the data behind, I've always been able to, controllers have been able to test them, but never the view before, and now I can, so development goes faster. Thanks.